So if you want to be happy, I would use Sector. But you know, there are more people using Hadoop. So if you want to have more friends, you could use Hadoop. So it really depends that way. Now that slide sort of helps you decide whether you want to be happy or have friends. This slide tells you if you want to understand, if you want to begin to understand how to design systems like Hadoop or Sector, what are some of the design trade-offs. So one of the things, so the processing, instead of MapReduce, the processing layer is called Sphere. So the compute services is called Sphere, the storage services are called Sector. So the first slide, this is about Hadoop distributed file system versus Sector distributed file system. This is about MapReduce versus Sphere. So the one thing that everything is, large data is about mainly data and disk. Occasionally you want things to be bound in memory. Sphere now gives you, allows you to bind things to memory. And for example, Gu and a student, Li Lu, did some work where we looked for large graph processing, what you gain by allowing you to specify certain things in memory. And that really can be quite helpful. I've already talked about the UDFs. The data exchange, I remember how when we filled the disk, the disk in here with data, then there was a pull on the reduce. For various reasons, UDF does a push, and for many applications, pushing can say, for that graph problem, it gave you a 46% increase just by pushing and using the push to specify the push to a particular location. So not only, basically, MapReduce pulls, and you can't specify the location. Sphere pushes, and you're allowed to specify where you push to. And that could be extremely important to preserve locality for many applications. There's a couple different notions of locality. I think we have a picture on the next graph, the next slide. I don't, I'll come back to it. But Sphere allows you to specify locality in memory before and after the UDFs in different ways. And in a longer talk, I walk you through that. There's a benchmark called Terrasort, and this is just, it's a pretty interesting benchmark historically. It doesn't really inform you very much about how you do data-intensive computing, but on this benchmark, Hadoop is, Sphere is about 2 to 3 times faster. Sector Sphere is about 2 to 3 times faster. There's another benchmark that the Open Cloud Consortium did that is sort of designed to give you insight into the type of statistics you might do on a large data cloud. And I'm not going to describe this benchmark. It's called Milestone. It's the abstraction of some very simple problems a number of us have worked with over the years. And these are the simplest problems I knew of that if you had, say, a petabyte of data and it wouldn't fit into a database, this was the simplest computation that I knew of that was sort of meaningful on sort of a petabyte of data and that you just couldn't do in a database. And it's a, I'm not going to try to describe it. It's just a particular analytic computation. Under there are a couple versions of Milestone, A and B. And so the take-home message, even if you never use Sphere, Sector Sphere, I want you to look at this slide just for 2 minutes because this tells you a little bit about how much we don't know about MapReduce style computing. So Hadoop under Milestone B on 20 nodes. This is with 10 billion transactions. And there's a bigger version on 100 billion and 1 trillion. So there's a data generator to give you 10 billion, 100 billion, or 1 trillion transactions. Hadoop takes 840 minutes with MapReduce. If I use Hadoop streams and do the Python streams, I can reduce that to 142. So at some level, with these numerically intensive operations, comes back, you're sometimes better off doing streams and writing a little. This was only, I think, 20, 30 lines of Python code total. And you get a reduction from 142 to 840. So just because you can do MapReduce doesn't mean you do it. You've got to look at the problem. We're still using Hadoop HF for scalability. And then Sector Sphere was only 43 minutes, so it's about 3 times faster than streams. So these numbers have stood up. They change a little bit depending upon what version of Sector and Hadoop you use. But at some level, Sector UDFs are 20 times faster than MapReduce. This is a picture where you could sort of see that there are more tools, more knobs in sector to control local control locality. Now these are new knobs. One of the main differences, if you're in a race to finish a project, is Hadoop has lots of knobs that you pretty much have to use to get the job done, to tune it. Sector basically has very few knobs that you have to use, and there's not much to tune out of the box. GU has put in a couple knobs for locality recently. They don't have to be used, but if they do use, for example, in this graph problem, they give you a little bit more bump. And so one of them is how do you push to get output locality. So sector is the fastest right now. If I have a warehouse full of disks, I'm sure Google's probably as fast, but I don't think any scientist has been able to buy his own copy of the Google system and run it in his own data center. So compared to Hadoop, sector is faster. It's easy to program. It does both streams, MapReduce, and UDF. It doesn't require extensive tuning. It's secure and reliable. I'm going to turn this over to GU and not do the apps, but we have apps in biology. We have apps in astronomy. We have apps in networks. And this is GU, so I'm going to take this off. I'll give this to Lance.
Stick this in.
Okay.
Upside down.
Oh. Hello. This is a test. Okay, good. Thanks for Bob. He just explained the technology of sector sphere. So in the next about 35 minutes, I will give you a very simple tutorial about how to use this system. We think that if you play with the real system, you can better understand the technology and give you more confidence to use this system. So basically, Sector is an open source software. It's written in C++. You can get it from sector.sourceforge.net, and it's a BSD Apache license. And Bob already described this. The software contains two components, and one is a distributed file system, and the other is a parallel data processing framework. And the most recent version is 2.4, and the next version, 2.5, will probably be released in sometime in September. Many people have already, they always ask us, why, do we need sector sphere? We already have many distributed file system like Lustre, like PVFS, TPFS, and even the Hadoop file system. But sector is really a unique file system. I mean, it's different from any of those, right? But there could be, it's similar to Hadoop because it's also run, it's a user space file system. It's run on a cluster of commodity computers. It provides file system level reliability, so it doesn't require very expensive hardware. But the sector is unique because it supports wide area networks. You can set up a single instance over multiple data centers connected by high-speed network, and it's application aware. It means a traditional file system, you don't know where the data is located. They don't want to know because it has to support transparency. But sector, allows you to know the location. They also allow you to specify the location. Although you don't need to, but when it's necessary, you can do that because it can improve the application performance. It's also compatible with many legacy systems. For example, if you install Hadoop file system some of your existing applications, it doesn't work with Hadoop anymore. You have to rewrite that. But the sector, in many cases, you can just simply do some wrap, like several lines of script. You can wrap the existing binary. They can still run over the over sector. And also, if you don't need any of this, you can simply use sector as a content distribution network. You can use sector as an advanced FTP server. You can do extremely fast data transfer using UDT protocol. Right? Sphere, on the other hand, provide it's a data processing framework, but it's different from many of this traditional workflow system or grid scheduler, because it's actually provide in storage processing. You process data where it's located. You don't copy the data out to another system. Can process and write the data result back. In Sphere, you process data where it's located. This is similar to MapReduce, on the Google file system, Hadoop, as Bob already described. So yeah, Sector and Sphere using this UDF model and it's not MapReduce, but we do support MapReduce. There's in Sphere you can use MapReduce API as well, but UDF is a little bit faster, and we do this transparent load balancing and fault tolerance, so it's much easier to program. You don't need to care about this. It's 2 to 4 times faster. So basically, this is a very simple system. It's a master-slave system. The master basically in charge of the metadata, take care of the user request, and this is a this compute clusters data center cluster in multiple data centers, and this is a security server can manage the user account, something other security policy like access address control, and this is the client side, and client communicate with this master system using SSL, and the data communication is on UDT, the protocol, and also it can be encrypted if you need, but it's optional. So there's one single security server. Right now, Sector uses its own user account, so it's separate from the Linux system account. But in the future, this could be expandable to connect to other security systems like LDAP, Kerberos, those stuff. Sector supports multiple master server, so it's and this master server, they are all active. They are not like Hadoop. One is name node, the other is just passive. But in Sector, they are all active. They can provide high availability and load balancing. Again, the master server stores the metadata of the system, and the slave node, they are just regular computer. They are internal disks. They are has a gig bits per second or 10G network card. And again, Sector is not a kernel file system. It's just a user space file system, and it relies on the existing system file system like ext, XFL to store data. Right? And the client side basically just the programming libraries, the tools you can use to access the system. So the server side right now is work on Linux only. Okay, but the